Good morning, students. Basujayanti Shubhashgalu. And let us move to the next topic, efficiency of transformer. First, tell me what is efficiency of transformer? What is efficiency? Basic definition of efficiency. That is output by input. Here, power output by power input. Due to the losses of transformer, the output of power of transformer is less than input power. Always output power is less than the input power. That is, output power is greater than the input power. Here, power output equal to power input minus total losses. What are the losses here? Two losses in the transformer, iron loss and copper loss. Power input equal to power output plus total losses. That is power output, PI, power output, iron loss, copper loss. The efficiency of any device is defined as ratio of power output to the power input. So for transformer efficiency can be expressed as power output by power input. What is input? Output plus two losses, output plus iron loss and copper loss. Here the copper loss equal to full load loss. Why the full load? The current is operating in the secondary side, that is the full load, that is I2 square R2E. Secondary resistance of equivalent resistance, that is R2E. I2 square into R2E. That is efficiency eta equal to output. What is output? V2 I2 cos phi 2 divided by V2 I2 cos phi 2 plus iron loss and copper loss. That is output equal to VA rating of transformer. What is VA rating? That is the total output of the transformer. The VA rating into cos phi, power factor. VA rating into cos phi into iron loss and copper loss into 100. That is percentage of the efficiency. For example, if a transformer is subjected to half load, then N equal to, that is fraction of the load. That is half load by full load. Suppose full load 1, half load is 1.2. That is 0.5 load. That is N equal to 0.5. That is N equal to fraction of which load is less than the full load. That is percentage of eta efficiency. That is N into VA rating cos phi. N into VA rating cos phi. N into VA rating cos phi. Iron loss. That is N square. Why N square? Because the full load copper loss. The fraction is N square. Suppose half load 0.5 square copper loss into full load. That is 100. N equal to fraction of which load is less than the full load. The next topic, condition for maximum efficiency. This is very important exam point of view, even though I condition for maximum efficiency. Derive the condition for maximum efficiency of transformer. Finally, you derive the iron loss equal to copper loss. How to derive? Using these two losses, that is load current at which the efficiency attains a maximum value denoted by I2M, and maximum efficiency is denoted eta max. That is, efficiency is a function of the load, that is the load current I2, assuming cos phi 2 is a constant. Once you constant cos phi 2, that is both the loss will be constant. That is secondary terminal V2 also assumed constant. So maximum efficiency differentiating eta by differentiating N2 equal to 0. That is eta equal to Vi2 cos phi 2, Vi2 cos phi 2, iron losses and copper loss secondary side, that is I2 square R2E. That is just differentiating dN2 by dI2, that is d by dI2. What is efficiency? Just you substitute the efficiency value, that is output by output plus these two losses. Next, differentiating V2 I2 cos phi 2 Pi I2 square R2E V2 cos phi 2 minus V2 I2 cos phi 2 V2 cos phi 2 2I2 2I2. Simplify that differentiating. The cancelling V2 cos phi 2 from both the terms we get finally Pi I2 square R2E 0. How to get this value? Just I2 square R2 minus 2 I2 square R2. You get I2 square R2 0. Finally, iron loss equal to copper loss. That is Pi equal to PCU. That is iron loss equal to copper loss.